Hey everyone, in this question we'll be solving unalike GCD and LCM. In this question we'll be given an integer x and you have to answer two queries. You'll be given with a positive integer p and the number of positive integers y. We have to find such that this condition should hold, like GCD of x and y to the power p should be equals to the LCM of x and y. We'll be given with x and we have to find the count of y, like what are the possible values of y, and we need to return the count of that. The answer may be very large, so we have to return this 10 to the power 9 plus 7. So let me show the intuition. In the question, you will be given x and p, and you need to satisfy a condition such that GCD of x and y to the power of p must be equals to LCM of x and y, and you need to find the possible values of y such that this condition holds. Now we know one of the formulas that LCM of x comma y is equals to x into y divided by GCD of x comma y. So we can write this over here. Now over here it will be same GCD of x y to the power of p. Now we can write x into y as GCD of x comma y to the power of p plus 1. Now if x has some prime factor, let's say e to the power of s into b to the power of t, y has some prime factor like e to the power of u and b to the power of p. Now what would be for this equation? It would be e to the power s into e to the power of u for x, and it would be b to the power of t for x, and e to the power u into v to the power of v for y equals to what the GCD would be. GCD would be a to the power of minimum of s comma u. Why this? Because GCD is the greatest common divisor. So what power of a would divide both s and u would be the minimum of s comma u into b to the power of minimum of t comma v to the power of p plus 1. For sure. Now if I consider only the value for a, what it would be? A to the power of s plus u, that is this a and this s. So this is s plus u equals to a to the power of minimum of s comma u to the power of p plus 1. Now if I consider only the powers, what it would be? That would be minimum of s comma u into p plus 1. Now minimum of s comma u, if I consider it as s now, what the equation would be? It would be s into p plus 1. After calculating, it would be p into s, and I need to find u. Why? Because I have the value for x, so I know s, that is e to the power of s, and with the help of this s I need to find the value of y, u, and by using that u I can find the value of y. So this is one of the thing. Now what if the minimum of s comma u is u? Now we can write s plus u as u into p plus 1. Now from here I can write that s equals to u into p. Now I want to find the value of u only, that is present in y, so that would be s by p. To hold this condition, s must be divisible by p, because u cannot be a decimal or anything, it should be an integer. So if s is divisible by p, then only this condition would hold. But this will always be true, because if you have s and p, you can multiply anything to get an integer. As both are integers, so it will result in integer itself. So we have this two condition. Now if to fill u, you have two values, and for filling v, For filling u, let's say you have two values, and for filling v you have two values, then how many total ways to represent y? Let's say to fill u, you can fill it with 1 or 2. That is the possible values for filling u. Now for filling v, you have two possible values, let's say 3 and 4. So it would be 1 2 1 3 1 4 2 3 2 4. So there are 1 3 1 2 1 3 1 4, not 1 2. So there are four values, that is 2 for this and 2 for this, multiplying both of them. So if there are two ways and there are two ways, I'll be multiplying. If there is like says the power of c is z, it's having one value, so I'll be multiplying it, and so on and so forth. How many possible values of the power, I can use those to find my answer. So it will be, if there are two ways, this will contribute in the second way. This is always possible. This will contribute in the second way. So when the second way would be possible, if this s is divisible by p, then only the second way would be possible. Else we will have only one way. So if t is divisible by p, then I could have two possible values for this v. But if it is not, then I'll have only one value. So by checking this, I could find each and every prime factor's possible value. So let me show the code and it will be more clear.
What I have done in this code is first I have taken each and every prime using the seed method. We can calculate the primes, and then I have just taken the prime factors for x because I'll be using those powers. So, and the frequency is representing the power of each prime factor. After that, I'll be tackling each query, and if p is 1, then the division as well as multiplication would be same. That if we are dividing by p or we are multiplying with p, both would be same. So we will have only one way to represent each and every power of prime factors for y. So there will be only one way. But if it is not, then I'll be checking that the power of one of the prime factor present in x, if it is divisible by p, then we have one more way to represent the power. That's why I'm multiplying it by 2 to, because it will be having two ways to represent the power. And after that I'm just printing my answer. So if it is not divisible by p, then we will have only one way. So multiplying by 1 doesn't affect anything. So if it is divisible, then only I'm multiplying with 2, and after that I'm just printing my answer. I hope you like it. Thank you for watching.